Hey guys, I want to show you a new tip on how to graph linear equations. So this is chapter 3.3, graphing linear equations into variables. We've already talked a little bit about graphing linear equations, probably mentioned that you can graph linear equations by plotting, but plotting is not the best way to graph. It only works for lines and maybe other parent functions. So we want more sophisticated methods as we learn more functions. So for lines specifically, we want to talk about how to graph using what we call the slope-intercept form. Of the equation of a line. And the slope-intercept form is usually everybody's favorite. It's a little bit easier to use than other forms of the equation of the line because it is just the form y equals mx plus b. So once you isolate the y, you have your equation in slope-intercept form. It's y equals mx plus b. Recognize that x and y are the variables for this linear equation, so we have to talk about what m and b are. M represents the slope of the line, which tells us how the line changes over time. So usually we write that as a fraction, as maybe the rise over the run, the amount of change in the y variables, the amount that the line rises versus or over the amount that the line runs horizontally. So the vertical change over the horizontal change. The variable b in this case is the y-intercept, which we represent as a point 0 comma b, and that's where we start our line. Remember that to graph a line you need 2 points. The y-intercept is 1 point that you get for free. To find a second point, you just rise a certain amount, run a certain amount to get to your next point. So these are kind of like our directions to get to our next point. So always begin at the y-intercept at b. That's our starting point, but again, let me emphasize that it's on the y-axis. It's the y-intercept. Slope-intercept form gives us the slope and the y-intercept. So for example, let's say I have the equation of a line, maybe something like let's do y equals 2x minus 3. Notice that this is already in slope-intercept form. The y is already isolated. If I write y equals mx plus b underneath it just to compare, I can see pretty quickly that m is 2, b is negative 3. So the slope, which is a fraction, rise over run, is just 2. To represent 2 as a fraction, I think of it as 2 over 1. This is telling me that for every 2 steps I take on the y-axis, I have to also take 1 step on the x-axis. So the slope is 2 over 1. The y-intercept is the point 0 comma negative 3. So that's where I start my graph. Let me just try to get a sketch for you. Alright, let's see if this works on my graph paper. Say I have my xy axis. Let's see, let's try it again. I think I got it figured out. Alright, well, it's not so straight, but here's my xy axis. And I'm going by intervals of 1. So if this is my xy axis, this is the x-axis, this is the y-axis, then the slope-intercept form of a line tells me to start at the point 0, negative 3. 0, negative 3 is down here. 0, negative 3. The point from 0, negative 3, I go up 2 steps and over 1 step. and then I go up 2 more steps over 1 step. I can keep doing this as many times as I want to get as many points as I want for my line, but what you should recognize between them is that from one point to the next, I go up 2 steps over 1 because my rise over my run is 2 over 1. It tells me to rise 2, run 1 from each step. Rise positive 2 and run positive 1. Rise positive 2, run positive 1. And then from there I can draw my line. More or less that. Maybe I should just use that to draw my axes. I'll try it again in a second. So let's try another example. Let's say I had... Alright, so let's do like the same type of equation. Let's try the equation y equals 3x plus 3. You know what? Let's make it a negative 3x, so that way we have an equation of a line with negative slope. Again, looking at this, you can see that the slope, the rise over the run, is the fraction negative 3 over 1. This is negative 3. Who does that negative belong to? As mathematicians, we really don't like the negative to go to the denominator. We want to think of it, I would suggest you always just move it to the top so that you can think of the rise over the run as negative 3 over 1. Then the y-intercept is the point 0 comma positive 3, because in this case b is positive 3. So that's where I'll start the equation of my line. Let's see if I can get my graph paper in here. Perfect. And let me see if I can draw my xy axis neatly. Ooh, there's the x. Let's do it again. There's my y. I guess I'll just leave it there. Maybe I could do this. There and there. Alright, perfect. So I want to draw my xy axis. I want to, again, go by ones. So let me make a little bit of a thicker dot. This time I'm going to start at positive 3. Start at the point 0, 3, 0, 3 on the y-axis. But now my slope is negative 3 over 1. That's telling me that from this point I have to rise negative 3. Rising negative 3 means to go down 1, 2, 3 steps and then to run positive 1. So what I was saying earlier is that we're going to always have our run be positive if we never put the negative in the denominator. So I'll just have to ask myself, do I go up or down? But then I will always run in the positive direction. This is the positive real numbers, so I'm running to the right in the positive direction. And all you need is 2 points. That will give me a line. But if I want a third, I can go down 1, 2, 3 again and over. And just keep going until you have as many points as you want. 2 is enough. 2 will give you the equation of your line. So if I make my line passing through those points, oops, the line looks something like this. Perfect. That's a line with slope negative 3. Now the equations of the lines won't always be in slope-intercept form. I could give you something like maybe 2x plus 3y equals 9. Where you have to isolate the y and rewrite it in slope-intercept form. So if you subtract the 2x over, you get 3y equals negative 2x plus 9. I subtracted the 2x to the other side, but I'm also knowing that I want it in slope-intercept form. I want the x term before the b term. So I've got the y term by itself, but I wrote it in mx plus b form already. Now I divide both sides by 3, meaning I divide everything by 3, so that y is equal to negative 2/3 x plus 3. That tells me then that the slope in this case is negative 2/3. I'm putting the negative with the numerator. I'm rising negative 2, and then my y-intercept is the point 0, comma b. So if I slap this graph in here, maybe off to the right. Uh-oh, it grabbed onto my, let's put it right here. Okay. There it is. Sorry about that. Then I draw my xy axis again. My xy axis goes vertically. My y axis goes vertically. My x axis runs horizontally. Well, let's just leave it right there. Then, okay, let's work with this. My y-intercept is the point 0b. Well, in this case, b is actually 3, right? So I can start at the point 0, comma 3 on the y-axis again. So I can make this a little bit thicker for a second. I start at positive 3 on the y-axis. That's right here. Whoops. Let's try that again. 0, 3 is right there. And then I also want to use the slope to create the next points. The next points are go down 2 over 3, rise negative 2, run positive 3. So from this point, that's my directions. Rise negative 2, go down 1, 2 steps, and then go over to the right, positive 3, 1, 2, 3. Again, the rise is negative 2, that's why I'm going down. The run is positive 3, that's why I'm going 3 in the positive direction. But unlike before, we'll just use the 2 points and create our line. The line should pass through these 2 points. It didn't change the thickness, but you get the idea. So you have to isolate the y, get the y by itself so that you can see the slope and the y-intercept. Notice the slope doesn't have the variable in it. The slope is just the number, negative 2 over 3. So once the y is isolated, it's in slope-intercept form, and I can graph. All right, so try it. There's going to be one on Math Excel, same as before.